I think we can start. We'll have a chance to get this link again before we dive into the hands-on part.
Can you announce that we'll be rolling out STAs in the back?
Yes, I have an intro as well soon, so yeah. All right, let's get started. Thank you everyone for joining for this pre-conference workshop on Intro to Earth Engine. It says JavaScript, but as soon you learn it's irrelevant. You're learning the Earth Engine API, learn how Earth Engine can help you with your remote sensing workflows. As we start, some logistics information. This workshop will go until 4 p.m. today. We'll have a lunch break at 12:30. And you have the map of the place here, and you can find yourself. Again, this class is going to be very hands-on, interactive. Feel free to take a break in between. There'll be a lot of time during the class where we're doing exercises. We are just answering questions. So feel free to drop in and out if you need to. Just a brief intro about myself. My name is Ujaval. I come from a traditional remote sensing background. I learned GIS and remote sensing on the desktop, ArcInfo, or DAS Imagine, and that was my world for a very long time. I was happy with that world till I joined Google in 2005, very early days of Google. And again, that world completely shifted because when you were here, the data volumes were large, there was a different way of working, and I had to learn how to code, how to build pipelines. And I worked at Google for 15 years, including for the Earth Engine team. Towards the end of my time at Google, I was doing this, going around teaching people Earth Engine, and I loved it. So I said, can I figure out a way to teach full-time? So that's what I do now. I have my own academy. I'm based in India, but I do online classes, and I taught people from across the world. I also published a lot of training materials that are openly licensed so people can learn from it. And I also worked on a book project. I'll be referring to the book project where it's, again, open access book here. So again, if you're never coded before, you are in the right place. If you have coded before, you say, I'm a JavaScript expert, you're still in the right place. So we're going to learn basics of Earth Engine. If you never coded before, we'll teach you the basics you need to get started. But today it's going to be about how to use Earth Engine for discovering data, doing the basic data processing, downloading data from Earth Engine, and doing some time series analysis. We have some TAs who are going to be helping us out. You can introduce yourself. Sam, can Emil?
Hi, everybody. Emil Charrington. If you're on Twitter, I'm at BZGeo. I'm also a big fan of Earth Engine and also the great work that Ujaval does through Spatial Thoughts. And so, like Zhu and Sam, also going to TA and also a Google developer expert for GE.
Yeah, we have a lot of awesome Earth Engine expertise here. So please feel free to ask some questions. Again, all of them have done some amazing work in Earth Engine. So we'll be happy to discuss and answer questions related to that as well. Just a brief about Earth Engine. How many of you have used Earth Engine before? Right, most of you. OK. I teach an Earth Engine course, and when I ask people how many people use Earth Engine, many people say yes. And then after one session, they said, I never knew this thing existed in Earth Engine, right? Because when you self-learn, you will learn only certain things that are useful to you. And today is going to be a chance to learn in a structured way to discover how Earth Engine was designed to be used. Earth Engine consists of distinct parts. The first one is the data. As geospatial people, we know data is our biggest challenge. Getting data, downloading data, processing data is kind of the bread and butter of geospatial analysis. Earth Engine comes with a lot of data that's already there. You just can access it directly. And that's kind of one part of Earth Engine. Sam runs the awesome GE community catalog, which has also got a lot of other data sets which are super helpful, where you can directly access the data in Earth Engine. Your computation, the reason you all are here is that a lot of times when you're running remote sensing analysis, you are limited by the amount of resources you have for data processing. Earth Engine provides you with a lot of computation resources. At last year's conference, they announced Earth Engine has about 500 million CPU hours of computation that is being used every year. And just think about it, I didn't even know how to kind of put that in perspective, 500 million CPU hours. And that equals to about like 100,000 machines running all the time. That's the power you have as an Earth Engine user for free, right? And that's amazing resource that you have. But imagine I give you all the data and I give you 100,000 machines. So go and do your awesome work. You say, I still don't know how to efficiently use all of those computation resources. So Earth Engine provides you with the API. API stands for Application Programming Interface, which is a fancy way of saying Earth Engine gives you a way to run your computation that efficiently utilizes all the computation. So today we're going to focus on learning the API, that how to do your stuff. How do you compute an index in Earth Engine using the API so that it can leverage all the computation and the data resource that it has, right? So API allows you to use Earth Engine computation effectively and do your analysis. And finally, Earth Engine also gives you a way to run and save your code. When you're writing code, you need a way to save your scripts, access it, run, see the results, etc. That whole interface is called an IDE. It's an integrated development environment. So Earth Engine gives you a browser-based IDE, which is great because you can just go to a website and start doing your Earth Engine analysis. Many times when I'm traveling, I can access it on my mobile phone and say, I'll just start my petabyte computation right from my mobile phone. Right? So it's very accessible. Another reason to kind of start with the JavaScript API because you have this not there on the Python side so that you can kind of easily get started with that. So all of this together forms the Earth Engine system. Earth Engine is a very mature system. It's been around for 10 plus years now, and it has got a lot of features. What can you do in Earth Engine? All of you have kind of dabbled with it. Some of you might be using it daily. If you're coming from a remote sensing and GIS background, you might say, can Earth Engine do what I do in my work? Well, let's see what Earth Engine can do. It can do image processing. So if you take a remote sensing class and you learned about any of this, you have capability in Earth Engine. So Earth Engine API has functions that can do spectral unmixins. It can run a kernel over your image and so on. Right? So all of those image processing tasks are built into Earth Engine. Many people don't know Earth Engine is also very capable GIS. It can do vector processing. So you can upload your shapefiles. It has got some data within catalog itself, and you can do all your spatial joins and buffers, etc. And again, it scales beautifully just like the imaging platform does. In the Earth Engine Fundamentals and Application, I wrote a chapter on vector analysis using Earth Engine. So you can check it out what you can do. And again, my main background was GIS. I was really curious to see if we can do all the GIS stuff I wanted to do. And again, it can do very large spatial data. Many times I have a data set with like 500,000 points. I want to buffer them and do some joins, upload to Earth Engine, do this, 5 minutes later, download it, and I'm done. Right? I don't have to deal with the desktop software. So do check out Earth Engine's vector capabilities as well. Terrain processing, DMs you can upload and do slope, etc. Time series analysis, this is a big part of Earth Engine where you can work with long time series data and do time series processing. Last year at Geo for Good, I gave a talk that demonstrated all of those capabilities. So if you are saying I want to do time series smoothing, I want to fit a polynomial to each pixel of my time series, etc., you can check out that talk as well. Object-based analysis, this is quite popular research. A lot of people who are doing their research work, they say, I want to do object-based classification. I want to do object-based stuff. Earth Engine has capabilities to do that as well, so you can run your stuff. Change detection, machine learning. Earth Engine is kind of custom built for doing traditional machine learning like random forest. It does this amazing, it scales beautifully. It's designed in a way that you can get your training data generated very easily. And again, it's very powerful to do a lot of machine learning tasks. You can do regressions. This is something that a lot of people are interested. I want to do yield prediction. I want to predict biomass. You can do regressions in Earth Engine as well. And again, compared to the other system that you might have worked with, it can do pixel-based regression. You don't have to aggregate it to a region. So you can have like a model fit to every pixel, which is quite powerful. You can do deep learning. Deep learning in Earth Engine is done via TensorFlow, and it's a loose integration, but you can use TensorFlow in conjunction with Earth Engine to do deep learning. Right, so you can see it's a lot of features in Earth Engine that you can do. If any of these things is familiar to you, that you're doing it, you can migrate your workflow to Earth Engine, and you can benefit from the computation and the scaling that Earth Engine provides you. What's more important than what Earth Engine can do is what it cannot do. Right? This is very important to know. Earth Engine is not designed to be the go-to platform for everything geospatial. Right? That's not the intent. Some of these are inherent limitations of Earth Engine, how it's designed. Some of them are features that probably they haven't built yet. But as of now, you cannot do certain things like you cannot create maps in Earth Engine. It's not designed for that. It's an analysis platform. So many people ask me, how can I add a north arrow? How can I add a label to that? And we have Gena, who has done some third-party libraries that can kind of hack together something to do this, but it's not really designed for that. So if you really want a pretty map, use something like QGIS. Export your data, or there's a really nice plugin for QGIS where you can stream your data from Earth Engine into QGIS, and then you can do your cartographic input. So again, not designed to be a full-fledged cartographic system. It's a 2D system, cannot do 3D stuff. It can do work with elevation data. There's like 2.5D, but it cannot do like 3D line of sight and all of those analysis. It's not designed for that. This is a big one. A lot of you might be doing some simulations and hydrological models. This is one of those limitations of Earth Engine where it is, the way it's designed to be a parallel computing system. And you'll learn a lot about how that works in Earth Engine, that the power of Earth Engine comes by the fact that it can divide this computation across many different machines. So I say, I want this computation, and Earth Engine says, okay, maybe I can use 100 machines in parallel to do this. When you're running a hydrological model, the output of each pixel depends on every other pixel. So Earth Engine has to compute every pixel. It cannot do it independently. It has to do it sequentially. And that's something that is not kind of, the system is not designed to do this. There are kind of, again, hacks and kind of workarounds, people do it, but again, it's not designed for doing this kind of hydrological modeling. Photogrammetry, you cannot do stitching, orthorectification, all of that within Earth Engine. There are some nice open source software if you're working with drone imagery. Use that. Once you have your elevation model, a DEM, a DSM, you can upload that into Earth Engine and use that. LiDAR, you cannot do LiDAR processing yet. Maybe it might be possible in the future. SAR interferometry, again, big Earth Engine made working with SAR data so much easier. I know many people who come and say, they are so relieved when they say, okay, just use Earth Engine for my SAR processing, which is so painful to do it on the desktop. Interferometry is one thing that is still not possible in Earth Engine. So again, if you're doing that, it's not possible. And there are a few other things, but these are kind of the main things that you cannot do in Earth Engine. Just want to pause here and see if there are any questions. Okay. So we have divided the workshop in two parts. The first part is learning the basics of Earth Engine system. How do you find data? How do you apply basic processing? How do you create, get your area of interest and export the data? So today in the first part, you'll select a region of the world that you want to work with. You'll find some imagery. You'll create a cloud-free composite, clip it, and download the data as GeoTIFF file on your computer. That's the idea of the first module. And I kind of encourage people to do this when people start using Earth Engine. Earth Engine can do a lot, but it's also a very steep learning curve. So if you say, I really want to do my whole kind of change detection workflow in Earth Engine from day one, that's going to be hard. But if you want to start using Earth Engine right away, you can just do this. Find the data, do pre-processing, download the results. Earth Engine is an open system. You can download the data at any point, and then use your traditional tools. This will still save you a lot of time. And as you start building your skills, you can move more and more computation towards Earth Engine. In the afternoon, we're going to do how to leverage Earth Engine for computation, time series computation. The goal of the session 2 would be you can draw a polygon over any farm of the world, and you'll get an NDVI time series for as many years as you want, right? And you can do this in real time. We'll see how to do this, and do this in a right way that Earth Engine allows you to scale that. Okay, so that's the thing. I like my classes to be very interactive, so feel free to stop any moment. We also have a lot of exercises and assignments. I have a lot of swag. You can win this nice bottles and mugs during the thing. So pay attention. We'll have quizzes, and you'll get this thing just to have a little bit of fun. The way I've structured the class is it's not going to be just me talking. If you've ever taken a programming class, you know that you cannot learn by watching videos or listening to somebody. You have to type code. Right? So we're going to give you plenty of opportunities to type the code yourself. I'll explain a concept. We'll start with a script, a script. I'll explain. I'll build the thing. I'll ask you questions. And then you'll have a C script, which is exercise. So you'll spend 5 minutes doing the exercise. The TAs are there to help you. I'm here to help you. And you can get to practice the code doing that. And it's going to continue throughout the class. Like 10 minutes of me talking, 5 minutes of exercise. And that's how we're going to do this. And it's going to be hands-on, so I encourage all of you to kind of work through and have your own laptop to do this. Lunch break. So now it's the hands-on part. So all of you can get your course material. This is the link to the deck. So first you can go to this deck. If you already have the deck, come to this slide, click this link here to add the class repository into your code editor. Right? This assumes you already have an Earth Engine account. If you do not have an Earth Engine account, you can sign up now. I have instructions here. If you need help with signing up, please let us know. We'll go and help you set up. If you already have an account, make sure you come to this slide deck here and click this link. Once you click this link, it should open up the code editor, and you should see under your Readers tab a repository that says Users Ujaval Gandhi G Introduction. And once you see this, we are ready to start. Right? So I'll give you a few minutes to get this set up. And if anybody needs help getting to this point, please raise your hands. We'll come around and help you. Okay. Some of you may have added my end-to-end Earth Engine course repository. The structure looks very similar, so don't get confused. Make sure you're working in the right repository. It seems very similar, the structure, but again, this is a slightly different structure of that. This workshop is actually a condensed version of the first 2 modules of my course. So even after the class, once you're done, you can go and continue working on the rest of the modules. Like network?
Looks like maybe just a few people with connection. Okay, perfect.
Cannot connect to it.
Okay. Yeah. So, yeah. Yeah. Click this button. It should come up. Yeah. Did you do the Google? Can you try the Google Case Legacy? No?
No internet. So maybe try a reboot of your computer once.
Usually either the legacy or this one fix it. Maybe try reboot and see if that helps. Anybody needs help, please raise your hand. Yeah. Got it? Okay. Yeah. I think there's some internet issue. Just refresh this. I should get it. Yeah, it should be. Yeah, make it bigger. It's still loading. Yeah, I got it here.
Okay, awesome, thank you.
Yeah, there's one person. I asked her for rebooting the computer. Yeah. Okay. Okay. All right. I think most of you are done. We'll move on. There are a few people still having internet issues. We're going to help you figure it out, but let's move on. So let's start our hands-on part. Let's do coding. Before we do the coding, I have a question for you. If you have coded before, what's your favorite programming language? People who love Python, raise your hands. Okay. Okay. Yeah. People who like R, lots of R people. Okay. Any other language that you work with? People who love JavaScript. Wow, brave people. Any other programming language that you work with? TypeScript, okay. Cool. Anybody who's not coded before at all? Fine. Okay. So we're doing JavaScript today, and if you see geospatial work, most people do the geospatial work in Python or R, and that's what we see today. I'm a Python person. I love Python. I've coded in Python all my life. I love the language. It's very intuitive, very easy to learn. JavaScript, well, how do I put it mildly? Like, I hate JavaScript. Yeah, so, and there are people who are kind of like JavaScript who are experts in TypeScript. And again, if you work with the language, you know it's not the easiest language to like because it's got a lot of idiosyncrasies and it's, you use it because you have to use it, right? And this was, when I first discovered Earth Engine, I was like, I will stay away from Earth Engine as long as I can because I don't want to do JavaScript. And I wasted a couple of years trying to get away from Earth Engine because I didn't want to do JavaScript. And once I kind of started learning Earth Engine, I discovered that you're not really learning JavaScript. Bad news for the JavaScript experts, you're not going to be able to use any of your knowledge in Earth Engine. Because everything that you need to do, you need to use the Earth Engine API. If I say, can you add two numbers, 1 plus 1, you cannot use JavaScript. You have to use the Earth Engine API. Say, can you do change detection? Well, you cannot do any of the JavaScript stuff, right? So the biggest mental block for me was, well, I don't want to learn JavaScript. And again, in Earth Engine, you're not learning JavaScript. You're just learning enough JavaScript to be able to define what you want to do and call the API. Right? All the real work happens in the API. And the API is exactly the same with Python or Earth Engine. Right? Even today, I want to do something in Python. I'll write my code in JavaScript because it's just easier to do this. And then Qisheng Wu has a library. We can just auto-convert my JavaScript code to a Python code and it just works. Because the difference is mainly syntactic. Right? There is no real work that happens in either JavaScript or Python or R. Right? So if you don't like JavaScript, you've never used it, don't worry. I'll teach you everything you need to know in the first 15 minutes, and that's it. Even today, if you ask me, I do not know any JavaScript to do any real work, right? I just use the API, and that's what you need to do. Okay? So, okay, you're not learning JavaScript, you're learning the API. But why JavaScript API? Well, it's the most easy API to get started. Because it's most mature. Google gives you the platform, the code editor, where you can access the API. No need to worry about authentication. You can see your result immediately, and just very easy for people to get started. The biggest thing is, as you're learning Earth Engine, you'll need help. In JavaScript world, it's very easy to ask for help. You click one button, you'll get a link that encodes all the code you've written. You can send the script to somebody, say, I'm stuck. I'm getting an error. They can fix the error, send you a link back, and you're done. They don't need to reproduce your environment and all of that. So very easy to ask for. The biggest thing that helps you while learning, that you can ask for help very easily. You can build apps. You can build interactive web apps in Earth Engine very easily. Earth Engine provides you with a framework where you can just say, I want a button, I want a slider, and you can code using the API very easy, and you'll get a real web app that you can deploy. That's only available in JavaScript. Right? For all these reasons, it makes sense for most users to start with JavaScript, even if you don't know JavaScript, right? Because it's the easiest to get started. Python API can do more things. And even today, though I start in JavaScript for all my projects, at some point, I'll switch to Python. And I'll tell you when it makes sense to switch to Python. Well, you have a project, you have a team, everybody's using Python. And you are the JavaScript person doing stuff. It makes sense to integrate, right? You say, I have everything in the same project, same language. It makes sense to interact with those other libraries in Python. You can do your work in Python. Automation. Let's say you have a script that says every Monday morning I need to run this, and it should send an email with the results. That kind of automation is not possible using the JavaScript API. You still need to open your script and click run. But if you want this to be run automatically on a server, you can use Python. I recently worked on a project for a client who wanted to deploy a dashboard that updates automatically based on this. And the developer just said, I just need this JSON at this location on the server every Monday morning. And I wrote my code in JavaScript, converted to Python, send the script to him, and I said, just run it as a cron job every Monday morning, and it extracts the data from the server and puts it there. Right? So again, you can use Python for automation and batch export. Many times people ask me, how do I export multiple images? I have 1,000 images I want to export. How do I automate, manage that? Again, Python gives you more control on that. So when you say I want to do a bunch of exports, I want to manage that, Python is the way to do this. We'll focus on JavaScript. Again, I have linked to this tutorial that I have on my end-to-end Earth Engine course, where it shows you how to take your JavaScript code, convert to Python, and use that. Right? So again, biggest thing we need to take away from here is focus on the API, learn how to use Earth Engine. Language is irrelevant at this point. Okay. Questions?
I was wondering if you can talk to the point that if you think about the JavaScript as well as Python API, they are both using the same endpoint. So the API itself is actually the same. The Python API and JavaScript API that we are talking about is just the wrapper around the actual API. So whatever is in the code editor is just a wrapper. So when you're calling, for example, e.imageCollection, it is hitting an endpoint. So in the tutorials page in Earth Engine, and maybe you're talking to this, there is actual REST endpoints that these APIs or these wrappers are actually hitting. So whenever we are using the word JavaScript API or Python APIs, we're using wrappers around the actual API. I just wanted to create the distinction because they're not actually different APIs. They're the same APIs we're hitting.
Yeah, it's a good point. And that's all I will show at some point where as soon as you hit the run button in your code editor, whatever code you written gets turned into a request that goes to the server. The server never sees your code. So if you write Python code or R code or JavaScript code and you hit run, it gets converted in your computer to a request that goes to the server. The server never even sees your API, sees your code. Right? So again, it's a way to describe what you want, and then the server will take care of that. So what we learn is enough JavaScript to be able to describe what you want to do. Say, I want this image, I want to take this region, and I want to create this index. Like, how do you describe that? The API function, but how do you kind of put that into sequence of commands? We'll use JavaScript for doing that. Okay, good point, Sam.